Greetings. I got a couple of questions about two specific problems on the homework, chapter 1 homework, and I thought I'd go over these. The first one was about the cosmic year question. So the setup was that you could say you could define this new unit called a cosmic year, and you're told, hey, one cosmic year is going to be defined as the lifespan of the universe, or that 13.8 billion years. Billion is 10 to the ninth years. And the problem elaborates, says, all right, now let's define this new unit that we'll call a cosmic day. And we say there are 365 cosmic days in one cosmic year. Oop. Cosmic day equals one cosmic year. And the question was, well, how many years that you and I experience? How many years in one cosmic day? And I got a couple of questions about this, and things I noticed. Several people would try a shortcut, and they'd say there are 13 years in a cosmic day. And that doesn't make any sense. 13 years compared to the billions that this universe has been around doesn't match up this time frame here. And so what I notice with a lot of my students is they're trying to shortcut. Just go into the brain space and think, what is the trick? Got it. I got the trick. I know the answer. And then it just doesn't work. And one thing I often notice with my students is that they don't do what I just did here. Just write it down. Right? I'm a big emphasizer in using your tools. Write something down to get a sense of this. In fact, by writing it this way, you can almost see the solution immediately. We want to know how many cosmic days or how many years go into a cosmic day. But we already have this relationship. If 365 cosmic days is one cosmic year, and we know what one cosmic year is, it's 13.8 billion years. So we can say 365 cosmic day equals 13.8 billion years. Well, then divide out the 365. One cosmic day is equal to 13.8 billion years divided by 365. And then we'll have the result. One cosmic day in the units of years. All right. If you compute that out, I've got it on my little cheat sheet here. This translates to about, rounding here, translates to about 38 million years. So write out your formulas, write out these expressions. Don't try and just keep it up in the brain matter and try and intuit an answer. Work with it, massage it. Other things I want to encourage you, keep track of units. A number without a physical quantity associated with it is meaningless. We want to keep track of the units. The idea of creating a cosmic year or cosmic day is to help us comprehend just how huge, how long this universe has existed. One cosmic day is 38 million of our years. So I hope this kind of helps you get a sense of just how long the universe has existed. And that's the power of us inventing new units. We can always translate the new units into the stuff that we might be more familiar with. So let's try another one. The other question that I most commonly got questions about was the Voyager problem. All right, so the setup was, here's your Voyager craft. Here's my rough sketch of the Voyager craft. And it's traveling at some velocity. It's about 60,000 kilometers per hour. Let me check my notes. 61,146 kilometers per hour. And we're going to fire Voyager 1 off to some distant star and ask ourselves, well, how long is it going to take to get to that star? Now, the distance the software gave you could vary wildly, so I'm just going to take a distance of, for me, I use 7.8 light years. That's the number I use. Whatever your number is, it's going to be the same process through this. So the question is, how much time is this going to take? The most common mistake I saw was just multiply or divide these two numbers in some combination and say that's the answer, plug it in, and then get frustrated when the software tells us that's wrong. And once again, focus on the units. We have kilometers per hour, light years, which is a different distance measurement from kilometers. So we're going to have to keep track of our units carefully if we're going to solve this correctly. The way I'd go about doing this, I'd say, all right, velocity. What's that defined to be? Velocity is equal to distance traveled divided by time. And we want to know time. That's the thing we're ultimately looking for. So I'll rearrange this. I'll move time to the numerator on the left-hand side, divide out velocity, and we'll say now that time equals distance divided by velocity. There's your formula. Right? How are we going to find the time frame? And let's plug things in. We have 7.8. I'll write Ly for the light year, divided by the velocity, 61,146 kilometers per hour. And this is where we need to be careful. Our units aren't going to match up nicely to compute this in something we'd understand. Right? So this is going to be a light year per kilometer per hour. This does physically have units of time, but now we need to work with this to write this in a way such that we get ultimately the years of travel time that we're looking for. So I'm going to clear the page. I'll rewrite this little bit here, and we'll start doing our unit conversions. Right? So our time is equal to 7.8 light year over 61146. I'm going to write it this way. This is kilometers per hour. All right. So first thing I'm going to do, light year kilometers. I'm going to do some conversion such that the light year is converted into kilometers. And that way we can start canceling out some of our units. So you can easily look this up. I don't bother committing this to memory. These are values. I just remember big number. And they're easy to compute or look up. A light year, 1 light year in kilometers, there is 9.46 times 10 to the 12 kilometers per 1 light year. Right? So that's our first step in the conversion process. You'll see the light years cancel out and the kilometers cancel out. And this is the power of writing our math with the units inside of it. Don't ignore the units. Don't do manipulation, skipping the units and just saying, what's the number? What's the number? What's the number? No, the number's not the too important part. It's the process. Keep the units around. It'll help you keep track of what you're doing. If you plug this result into a calculator, you'll get something that is, look at my cheat sheet now, 1.207 10 to the 19th, is that right? 1, 2, 3, 4. 10 to the 9th. Let's see here. Our units are going to be 1 over hour or 1.207 10 to the 9th. Let me write that a little bit cleaner. 1.207 10 to the 9th hour. The 1 over hour can be flipped on the numerator. So now we have it's going to take Voyager 1 about 1 billion hours to get to that distant star. All right. But the question asked us for years. So we need to convert these hours into years. So let's do that next step. 1.207 billion hours, 10 to the 9th, hours. And we can say, hey, there is 1 day and 24 hours. And we can say there is 1 year and 365.25 days. Once again, look at the units. Hour cancels hours. Day cancels with day. We'll be left with years. And let's quickly pull a calculator, do that. 1.207 e to the 9th times 1 divided by 24, 1 divided by 365.25. I get 1.4 10 to the, let me count this out, 1, 2, 3, 4, 5, 10 to the 5th years. So, I hope this was helpful for you, seeing this kind of process, working things out. What I'll always encourage all of you, have a notebook, right? Just carry your notes around, write out your math, write sentences like we did before. I'm going to go back a bit. When you did this way, write the sentences out, carry your units. These are great ways to really reinforce those skills, reinforce the ability to manipulate these things, and pull out those meaningful results. So, coming back to the end. I hope that answers all your questions. Always feel free to reach out to me, ask me for any more, and I'll see you all later.